Hello, welcome back to my bench. Today on the bench we have another one of these Orban Parasounds, model 111B. We did one before. This is a dual reverberation unit, and it has, honest to goodness, boing, boing, boing springs in it. I did another one of these things. I'll leave a link up there in the corner for you, right up there somewhere. And on that one, I forget what all we did to it, but anyway, we did a tune-up on it and everything and showed you how to do that. If you want to see how to do a tune-up on one of these, go take a look at that one. This one's got a different problem. So let's get the scope up here and I'll show you what's going on. There's the scope. I guess the best way to do this is if I go... first of all, let's take a look at the manual. We're going to do the right channel here, and I'm going to start because I got to figure out where this all starts from. I'm going to start from the input, which is over here in this TLO72, which is IC102, which is up here in the corner. I'll show you in a minute, and then go through this 709 and over through the other half of IC102, which is the B version. That goes out to the springs and comes into this stuff over here for amplification. Well, amplification and buffering. And then into the rest of the stuff through this EQ module and out up to here. So, first of all, let's take a look at the scope and I'll show you what's going on. When I turn this on, let's turn on channel 2. There. If you look at that, you can see that is noise. That's a lot of noise. I don't know if I can spread this out a little bit. Yeah, there you go. Bring it down so I can see it. What does that say? That says 750 kilohertz. Right down here on the bottom. So that's a 750 kilohertz signal on there. So it's oscillating somewhere along the line. We got to find out where that oscillation's coming from. So, first things first, of course, let's check our voltages, make sure that they are what they're supposed to be. There is the meter. We'll check them on the ICs. Here's pin 4, minus 15 volts. That looks good. Here's pin 8, plus 15 volts. That looks good. I don't know where. And that's my basically 12 volts, and that looks okay too. That's on the 709 over here. Okay, so voltages look all right where they're at. So let's start doing a little bit of tracing here and see what we'll come up with. I've got the input going to the right channel this time. So if we look at the schematic, we're looking at pin 7 on IC102. IC102 is right over here. So if we look at, I'm on channel 1. Look at pin 7. That's kind of garbage. Okay. Pin 1 is after. That's awful looking. Okay, so let's go on out to this IC7 709 pin 6, which is what it says in the manual. Oh, wait a minute. We're still down on microseconds here. Okay, or on nanoseconds. Okay, here's 500 microseconds. So we have an oscillation there. I can bring in some audio but that's definitely an oscillation on pin 6. So that would be right there on pin 6. So let's back up one to pin 7 of IC 102. IC 102 pin 7. It's still got something on it. Let's see, that's on 2 volts. Whoops. Yeah, it's still got something on it. So if we go one more forward, it'd be pin 1. Oh yeah. We've got, now this is a times 10 probe. So we're looking at 20, 40, 60. We're looking at a lot. That's a bunch. I wonder, these pots down here that we've looked at before. Here, I forgot to bring the scope up. I'll show you. If I look at pin 1 right there, that's a ton. Here, pin 6 is before it, and it goes through and that's a ton too. I wonder if it's doing the same thing on the other side. Pin 6 on this one. Yes, it most certainly is. So it's oscillating. Where in the world is my oscillation coming from? Let's see if there's something wrong. There is a distortion. If we look at the manual again, there is a distortion null right here, this R120, which R120 is this one right here, which is this one right here. So let's look at pin 6, and we'll give this a little tweak. Well, I tweaked it to death and nothing's happening to it. Alright. So this is everywhere? This distortion is everywhere? Let's see. If I go, let's go down here to this guy. Most certainly is. Okay. How about little trick here for you. I'm going to go to the audio ground, which is back here in the back on the outputs or inputs, it doesn't matter. There's the audio ground, and now I'm going to go to ground, and you get a crazy 60 hertz signal, of course, but I can drop this down. See all that noise in there? Whoops, where are you, scope? See all this noise in here? That's between ground and ground. I'm still picking up some sort of an oscillation. That should be pretty clean. So let's try a different audio. Okay, this is ground. Okay, that is actual ground to ground, so no. All right, I think I know what's wrong with it. Because I've seen something like this before. Okay, we are going to take a look at the power supplies. Here is the plus 15 volts. There's the plus 15 volts. That's just basic noise from the scope. Here is the minus 15 volt. Oh, yeah. There it is. There it is. Kinda what I thought. 776 kilohertz. and pretty darn stable for an oscillation. All right. The power supply capacitors have been changed, but I think I know what's wrong with this. Let's get the solder sucker up and running. Okay. It's ready to go. What I'm going to do is, if you look over here, these are your plus and minus voltage regulators, LM3915, 3815. These things need bypass caps, or they will break into oscillation, and the oscillation is going to be anywhere from, oh heavens, 750 kilohertz. I've seen them up to 10 megahertz. I think I pointed this out on a 528E that I repaired one time. So we're going to make sure everybody's off. It's off. And I'm going to take these out. They are where? Here's one right here. Okay. Come on. You can do it. And the other one is over here. I think. Yeah, it's wiggling. Right there. So what are these? These are 15 microfarads at 25 volts. Let's get down the little meter thingy here and test them. See what it says. I'm almost positive about this. All right. I don't know if you could see that. That one is reading 900 picofarads. That capacitor. Yep, it's no longer a capacitor. It's two pieces of wire connected by air. Let's try this one. See what it says. Alright, this one says 20. If I can get it so there's too much light. It says about 20 microfarads at, what is that, 9.9 ohms. So both of these are shot. One is nothing and the other one's out of tolerance and high ESR. So I gotta find a couple of 15s or something. I'll be back in a minute. Okay. Okay, I found some. Here's a closest I got's 22s. So which way did these go in? Look at the manual again. They are up here. So this is C304 and C303. Let's go down and take a look at where those went. Here's C303 and 304. They are right off of the output of the 7815, 7915. That's what I thought. They'll give you some problems. These are the input capacitors. They appear to have been changed. At least I think so. Yeah, they definitely. But these here have not. So let's put these in. Again, which way did they go? Where am I? Up here. Okay, so this one goes with plus towards there. Right there. These are 22 at 25. That shouldn't make any difference whatsoever. I mean, capacitors are 20% to begin with, and the other one goes with plus this direction. I'm glad to have the manual on this because there's nothing marked on the board as far as where they go, which way they go in. All right, so there's that one and that one, and yeah, these guys over here, they appear to have been changed. Those are 470s at 50. Okay. We can cut these off safely because we know the other ones are bad no matter what. And clean it up just a shade. All right. There we go. So let's turn it back over again. What did I lose back here? One of my wires is falling off. That's the one going to the scope. That would be this black one and this red one. You can't have wires made up for every occasion. I've discovered that. Okay, so let's get the scope back up here and put it on channel 2, which is our input, or our output. Turn the bench back on and turn this on. Okay, we got to slow this down a mite. Aha! Ta-da! Look at that. Yep. 1,000 hertz. Perfect. That's the output. Now let's take a look at what we were looking at before and see what it looks like. This is pin 6 of that 709. Put you back on. Put channel 1 back on. Get rid of you. There's pin 6 of the 709. Wow. I don't know what that is. That might be scope problems, but at least it's a sine wave now. Anyway, here's the output, the negative 15 volts on that IC. Nothing, looks good. Here's the positive 15 volts. The negative was our problem. Let's take a look at that and crank up the sensitivity. Well, we got 20 millivolts. Okay, yep, there's nothing there anymore. Nice and clean. Okay, all right, now, some of you are going to say, well, why didn't you just measure that with your meter? You know, your voltmeter, an AC. Well, that'll fool you badly. If you measure something like this, especially if it's way up in the megahertz range, your meter is not going to read it. Most meters won't measure that kind of stuff. Heck, some meters won't go over 200 kilohertz. They just won't. So you're going to look at it on AC and you're going to go, well, that's fine. That looks good. So I do not trust the meter when I'm checking for noise on a line on one of the rails. It just I just don't. But it's definitely solved our problem. Let's take a look. Let's take a look at our output again, just for fun. This is my let's see which one. I always get mixed up on which one's which. The big outside button is the input level, and that's fine. And the outside knob is the output level through the through this little two band equalizer they got here. So if I take my yeah, what do you call this thing? Function generator. And right now it's on 1,000. It comes up at 10,000. If I take this to 5 kilohertz and get the scope back up, there's my scope. Let's see what this does. Okay. And we'll go on mid-range, bass, mid-range. And it is affecting it a little bit. That's maybe too much for it. Tell you what, let's go the other... Oh, wait. Well, the reverb's working. Let's take this down the other way. Let's take this down to 60 hertz. Get the scope back to where we can see it. And see if this bass has any change on it. Yeah, it does. A little bit. These actually, the bass and stuff works off of this, the reverb, more than it does the input or output. But it is affecting it. See, there's bass as high as I can turn it. There's bass as low as I can turn it. So yeah, that's working. And the reverb percentage, that's pretty active. And that's a whole lot more active. Oh yeah. So, yep, she's working. Working good. Only problem I got to do is on this one now, I got to order another one of these. And they're $6 a piece. Unfortunately, and they blow out. It's just a little neon bulb that goes on here. It's got its own winding, its very own winding on the transformer. Okay, guys, there you go. Real simple. I'm going to do a quick alignment on this thing, order the light bulb, put it in, and we'll be ready to go on this one. But if you get a something that has a plus and minus supply, that's like the only times I've ever seen this happen. If you get something that's using a plus and a minus supply, and you see oscillations everywhere. I mean, I had oscillations over here, farther down the line. I had the very first thing that it ever saw coming into it, and it was just everywhere. It was even between audio ground and ground, chassis ground. If you see that, you can pretty much bet your bottom dollar. You've got LM39 15s and 14s, or 39s and 38s. You can bet your bottom dollar pretty much that you got oscillation on those outputs, because that is just what they do. All right, hey, thanks for stopping by, guys, and give this a thumbs up if you like it, and don't forget to subscribe, and if you want to support me in a more direct fashion, I do have a Patreon page. Patreon.com/AERVblog, and that would be absolutely wonderful. So thanks for stopping by, guys, and until the next time.